Hello, this is part two of the heart. We're starting out with cardiac output, and that is on page, let's get the page out here. Uh, Page 285. So this is just going to help you to understand some terminology and to know what things mean, and it'll help you a lot in when you're discussing patients' problems, when you're learning about your patients in nursing home, in the hospital. So this is some terminology. We're going to start off with cardiac output. Cardiac output is the heart rate times the stroke volume, and it refers to the amount of blood the heart pumps in 1 minute. There's a calculation that in order to determine how much the amount of blood the heart pumps in 1 minute, use this calculation, which is heart rate times stroke volume. The average resting cardiac output is between 5 and 6 liters per minute. Cardiac output increases with activity. The only ways to affect cardiac output are to change the heart rate or change the stroke volume. So let's look at factors affecting the heart rate. So the heart rate, or the pulse, is the number of times the heart beats each minute. Newborns have heart rates about 120 beats per minute. Young adult women have heart rates of 72 to 80 beats per minute. Young adult men have heart rates of 64 to 72 beats per minute. A persistent pulse rate slower than 60 beats per minute is called bradycardia. A persistent resting heart rate greater than 100 beats per minute is called tachycardia. Although the heart generates and maintains its own beat, the nervous system can alter the heart's rhythm and force of contractions. So if you look here, it talks about the medulla in the brain center, and the brain contains a cardiac center. In turn, the cardiac center contains an acceleratory center and an inhibitory center. So factors such as exercise and stress stimulate the acceleratory center, and factors such as a rise in blood pressure stimulate the inhibitory center. So the inhibitory center, let's start on the right-hand side, sends signals via the parasympathetic nervous system, and the parasympathetic nervous system sends signals via the vagus nerve, which secretes acetylcholine, to the SA and AV nodes, and it slows the heart rate. On the other hand, if you have factors such as exercise and stress, this acceleratory center sends out impulses via the sympathetic nervous system. The sympathetic nervous system sends impulses through the cardiac nerves, which secrete norepinephrine, to the SA node, the AV node, and the myocardium. This accelerates the heart rate and increases the force of contractions. So these are some of the factors that affect heart rate. The input to the cardiac center in the medulla, it receives input from multiple sources. The proprioceptors signal changes in physical activity. This allows the heart to increase output before the muscles demand more blood flow. The baroreceptors, or pressoreceptors, are pressure sensors. They detect changes in blood pressure. If blood pressure falls, cardiac output decreases. The cardioacceleratory center then stimulates the heart to beat faster and maintain cardiac output. If blood pressure suddenly rises, impulses will be sent to slow the heart rate, decreasing cardiac output and lowering blood pressure. Chemoreceptors detect increases in carbon dioxide, decreases in oxygen, and decreases in pH. In response, the sympathetic nervous system increases heart rate and stroke volume to circulate more oxygen. So this is really important concepts to understand, and in relationship to our nursing interventions, in relationship to medications that are given. And so understanding these concepts will help us to understand if our patients are experiencing a lowering or decrease in their cardiac output, and how to help them with that. So this is on pages 286, 287, talks about emotions, Fear, pain, grief, and anger all affect the heart rate. This occurs because two almond-shaped areas of the brain called amygdala are key players in the formation and storage of memories associated with emotion. It is thought that stimulation of the amygdala, such as by emotion, causes it to send impulses to the autonomic nervous system. So anxiety, fear, and anger all cause the heart to beat faster. In contrast, grief slows the heart rate. It's also interesting that just the thought of doing something frightening, such as skydiving or taking a plunge off the high dive, can make your heart beat faster. Actually, watching a movie of a roller coaster can make your heart beat faster, especially me, because I don't like roller coasters. I digress. So, factors that affect stroke volume. You have the preload, the contractility, and the afterload. This is terminology to try to understand what affects stroke volume. The preload is the amount of tension in ventricular muscle before it contracts. More blood, more stretch. Think of shooting a rubber band. The tension or stretch placed on the rubber band before you shoot, that's preload. So you stretch it out, that's the preload. Contractility, let's go back one, is the force with which ventricular ejection occurs. The more the ventricle is stretched within limits, the more forcefully it will contract, and this is Starling's law of the heart. The amount of blood in the ventricle at the end of diastole, that's the relaxation cycle of the heart, it determines how much the ventricle is stretched. So the more blood returned to the heart each minute, the more forcefully it will contract. Too much blood, however, can overstretch the heart's muscle, causing it to lose elasticity. For example, the more you stretch the rubber band, the more it will contract when it's released, and the farther it will fly. Likewise, an old rubber band that has been overstretched is not as elastic as a new one and will not fly as far when released. So the greater the stretch, the more forceful the contraction. So afterload refers to the forces of the heart. It refers to those forces the heart must work against. So an increase in afterload decreases the stroke volume. So the heart must work against the pressure of the blood in the arteries. An increase in afterload, such as high blood pressure, it opposes the ejection of blood from the ventricles, which leads to decreased stroke volume. For example, if you try to shoot a rubber band underwater, the pressure of the water, the afterload, will resist the forward movement of the rubber band. So view this animation on preload, contractility, and afterload. So the question is, cardiac output equals what? What's the definition of cardiac output? It is heart rate times stroke volume. So let's look at left ventricular failure. The blood backs up to the lungs, shortness of breath, pulmonary edema, and coughing result. So prolonged high blood pressure or incompetent heart valves, it makes the heart work harder and it weakens the ventricles. And those have to contract the most forcefully. If the left ventricle fails, it falls behind in ejecting all the blood it receives from the lungs. Blood then backs up to the lungs, resulting in shortness of breath, pulmonary edema, and coughing. In right ventricular failure, the blood backs up into the vena cava and peripheral vascular system. Generalized swelling, enlarged liver and spleen, pooling of blood in the abdomen, and jugular vein distension results. And this often occurs in chronic lung disease. This is because diseased lungs make it more difficult for the right ventricle to pump blood into the pulmonary circulation. This strains the right ventricle and over time can lead to right ventricular failure. When the right ventricle fails, it falls behind in ejecting all the blood it receives from the systemic circulation. Blood backs up to the vena cava throughout the peripheral vascular system. So you're going to see swelling throughout the body. enlargement of the liver and spleen, pooling of fluid in the abdomen, which is called ascites, and distension of the jugular veins. Failure of one ventricle places an added strain on the other ventricle. Eventually, both ventricles fail. Okay, that concludes this portion on the heart. Thank you. This ends part 2.